Hello, this is a video on understanding the results of transformations. There are four types of transformations: translation, reflection, rotation, and dilation. We're going to see in this introduction that the first three here, translation, reflection, and rotation, do preserve distance. Dilation is stretching or shrinking. If we look over at the 8th grade Common Core State Standards, we see that 8G1 says that students are to understand congruence and similarity using physical models, transparencies, and geometry software. Verify experimentally the properties of rotations, reflections, and translations. Now, I'm going to switch back to my camera here. When they talk about transparencies, you can use a transparency, or you can use patty paper, or you can use wax paper. Patty paper can be purchased. It is actually designed to be the wax paper that's going to go between hamburger patties, but it also makes a nice math manipulative. It doesn't work very well for an online class, so I'm going to give this as a brief introduction, but just to give you an idea, here I have triangle ABC on my piece of wax paper or patty paper here. And if I fold this, one of the things that's nice about wax paper is when you fold it, the crease kind of turns white and you can see where the crease is. And then what you can do is take your pencil and trace over the top here to get the image under reflection. So I folded it and I've traced over the top. Now if I open it up, we can see the original triangle ABC over here on this side and the reflection A prime, B prime, C prime on this side. One of the things that we're going to notice right off the bat here is that ABC here is going in a, looks like counterclockwise direction, whereas the image over here, A prime, B prime, C prime, is going in a clockwise direction over here, trying to read backwards. So orientation is not preserved because there's a flipping over action with a reflection. So if it was a face-to-face class, we would do more with patty paper, but since it's online, I'll just leave that as an example. The next thing I'd like to show you is an app that is available for the iPad. It's called the Transformations app. I believe that it does cost 99 cents, so you may not want to buy it. This is an example of a transformation. And here is an example of a rotation. And this one is going to be a rotation of 180 degrees. And as you can imagine, this can also be done with patty paper. And they also have some questions down here at the bottom and so on. I tried for about 45 minutes to make a video of this, but I could never get the sound to work. I apologize for that. This Transformations app is available on the iPads in the Math Resource Office in Morgan 209 if you're near Macomb. Now I'm going to go over to GeoGebra and take a quick look at the apps that I've prepared for you, and I would like you to investigate these in greater detail. This is the Explore Translation app. The original points are A, B, and C. A prime, B prime, C prime is the image, the result of the translation. And the translation is this vector here from D to E. And so notice what happens here. We're going to go 3 units to the right in an X direction and 1 unit up in a Y direction. So A starts out at 4, 3 and comes to the right 3 and up 1, and the result is 7, 4. If I move this point E up here, now I'm moving 3 units to the right and 2 units up. Now, if we use our properties here in GeoGebra, let's say that I want to see the ordered pair for point B. What I can do here is select point B, and then right-click and go to Settings or Properties. And then right here where it says Show Label, rather than just showing the name B, I'm going to show the name and value. So this is the point 4, 2. So you might experiment with this. For example, here we're taking the point B and going 1 unit to the left and 1 unit up. One of the things that's very interesting about translations is this vector here has its tail at the origin. However, the tail does not have to be at the origin. Let's say the tail is up here and the head is here. Notice that I'm still going 1 unit to the left and 1 unit up. A vector is a directed line segment. It has a tail and it has a head and it has an arrowhead pointing for the head. Now we're looking at the Explore Reflection app. And you can manipulate the original points here if you like. You can also manipulate the line of reflection. So I'm going to put the line of reflection right on the y-axis here. Actually, we need the axes labeled. Let's go ahead and change the, I think I can change the x-axis, and here's the label. Yes, Dr. Olson, always label your axes. The y-axis needs to be labeled with a y. Okay, so this F here, you need to be able to reflect across a 45-degree line with a slope of -1 going through the origin. Notice here that the point A, which is 6, 1, becomes the point A prime, which is -6, I'm sorry, -1, -6. So you need to find some patterns for yourself there. Please notice things and post those. Please wonder things and post those in the discussion area. This now is the rotation app, and I am rotating around point D. Oftentimes point D is at the origin. For example, if we rotate through 0 degrees, it does not change the triangle at all. Here's a rotation of 90 degrees. Here's a rotation of 180 degrees. Here's a rotation of 270 degrees. You might think about that and think about what a rotation of 270 degrees would mean. It's also equivalent to a rotation of 90 degrees in the opposite direction. So it's going to be important for you to think about what happens to these ordered pairs. Notice that when the point, for example, B comes down here to the point of intersection, when the point B is on the center of rotation, the point B prime is equal to the point B, so we have a fixed point. Now we have the dilation. For a dilation, we need to have a center point. And this is the center of my dilation. It is oftentimes the origin, but it would not have to be the origin. We also have a scale factor. The scale factor is going to be changing the size. So this is not a distance preserving mapping. If your K value is 1, this means you're multiplying everything times 1, which leaves it the same, the identity property. So let's put K here at 3 perhaps, and we can see that the ordered pair 3, 2 becomes 9, 6. And this is the case because the point B here, the point D is at the origin. Notice that the K value can be a fraction, for example, 0.5. And now the triangle has gotten smaller. So B prime, C prime, A prime is a smaller triangle. You might want to also experiment with the center of rotation moving away from the origin. Notice here we have a ray emanating from the center through point B going out through B prime, center of dilation, through A going out to A prime, and we also have a line from D to C going out here. So it's like rays of sunlight emanating from point D. Please experiment with the Dilation app. Our objectives here are to be able to find the image of points under each of the 4 transformations and understand and use the properties of transformations. What I'd like to do now is take a look at what I call the detailed transformation objectives. And I don't intend for this to be intimidating. I hope this is helpful. For each of the transformations, the given points can be given in a variety of ways, and the transformation can be defined in a number of ways. For example, let's talk about reflection. Here's what you're given. You might have a point on paper. You might have an ordered pair, and maybe there's no diagram given. You're going to be performing a reflection. You need to be able to handle a horizontal line, a vertical line, a line of slope +1, and a line of slope -1. And ultimately, you're going to be finding the image point. Similarly, for translations, rotations, and dilations. So we're going to be discussing this and posing some questions, and I hope you pose some questions in the discussion area. I am going to be having another video where I take a look at our textbook, but I think I'm going to bring this video to a close.